Okay, so for assignment 4, part A is basically using the if conditionals. You can use if else or else, just if. The goal is to be able to have number x and y. You have to know if it's going to be int or double or float or what. And the assignment is that you can basically input different x and y, and then it's going to show the condition. For example, x is greater than y, so condition is true since x is the variable right here. So you can use this by using fprint or a printf or a cout. You know how to do that by now. Cout and printf. You basically, right now, it's just using puts. So puts is going to be a line of comment, or it's going to be hard-coded as x is 42. So if you change this number, this wouldn't change. What we need to do is that when you change this number, you print the new number that you printed. So notice that here you have a if for 42, another if is greater. You're free to do whatever you want as long as you have two numbers and you say condition is true for x greater than y and print x with the variable using either cout or printf. So it's a very easy homework. You basically have to change only a few lines here in your declaration. For part B, the homework is similar. It's also very simple. We're gonna use the same setup, except for now we're gonna ask the user, say for instance, cout, what is the type the first number, and then you're gonna get this number with cin in variable x or variable y, whatever you want. So this could be x, and this is a type of variable that you know by now is a float or double. And then you're gonna print other cout and then get another c input, console input with c input with y equals 5.2 or b, whatever name of the variable you choose. And then at the end you have to plot or print or output which one is greater. So the user should be able to input whatever number, and your code should be able to tell you which one is the largest. So sometimes this x is going to be larger, or sometimes y would be larger. The key is the code needs to be able to tell you which one is the largest. Okay, so those are assignment for part A and B, and for that we have until next week, till the 30th. It's pretty simple, but if you have questions, you can contact me. So let's continue with, we talked about if else. We already know that if else will execute a block depending on the conditions. If it's true or false, you can put any conditions you want in your block. This is pretty much what we're going to do for assignment 4, part A and part B. We also talked about your block being as large as you need to, as many conditions, as many tasks as you need to run in a condition. But if your condition is not going to happen, then this whole block is overlooked. And then it jumps into a block that the condition is true. And then if this condition is not true, else, meaning that this block is going to be executed. So for instance, if it's raining, we're staying home. Else, we go to the movies. And you check it's not raining, then we go to the movies. So this is how if else works. You do one or the other. And you can have nested conditions such that if the first condition is false, then execute the second condition. But if that condition is false, then you can have another bifurcation, and you can have as many cases as you want. And often this is used for many applications such as controls, robotics, you name it. This is a very common setup where you need conditions to be evaluated throughout the code. There's another one which is very common, which is the else if. So remember that if you have if and then you have else, your code will only execute one or the other. But if you have several things that you want to execute, then you can put if, else if, meaning that if this doesn't happen, then something else might happen. But if that doesn't occur, then something else might happen. But if that doesn't happen, then finally you want something else. So for instance, you have a variable which is equal to 3. So you check if x is greater than 10, output x is greater than 10. But 3 is not greater than 10. Therefore, this is not going to be executed. Instead, the compiler is going to check else if x is greater than 7, then put cout print 3 is greater than, well, 3 is not greater than 7. Therefore, this is not going to be executed. Next block. If x is greater than 5, well, x is not greater than 5. Therefore, else, yes, if nothing happened else, you will execute this. And x is less than 5, correct. 3 is less than 5. If one of these happened, then the else block wouldn't be executed. So one important part of this class is numerical techniques, and we're gonna talk about them more later, but we're gonna introduce a very common technique, which is numerical interpolation. So there are two things. There are interpolation and extrapolation. So extrapolation. And interpolation is, assume you have a curve of x and y, and you have certain data points. You have experimental data points. But you want a point that you didn't take, however, is somewhere in between these 2 points. So numerical interpolation lets you find the new point based on data that you already had. So this is interpolation because it's in between the points. Numerical extrapolation is a little bit more dangerous because for interpolation you have a domain and a range known, but for extrapolation sometimes you don't know the limits and you still needed to have some data, and you say, well, I only have these data points, but my data point is going to be all the way out there. So I'm going to extrapolate and then see what point that is. So that's usually how it's done. It's not very common to have extrapolations for very large numbers because usually systems have an envelope of operation, which is this envelope where, if for instance a pump or a compressor, if you instead of cooling 4,000 BTU home compressor, you need instead of cooling a 1-story building, you need to cool a 2-story building, then the compressor has to increase the size, the shape, the power, the capacity. So same systems, mechanical and electrical systems, have a limit of operation. Therefore, careful with extrapolation because the limit of operation sometimes will tell you that perhaps you can extrapolate, and that will help you know if you need a different equipment or a different system that is greater. But nonetheless, we're going to do interpolation, which is this equation right here, and basically says that if we have a point A and a point C, so this is, for instance, A and C, and we know the value of fa, the function evaluated at A, and the function evaluated at C, so these two, and we know where the corresponding x and y limits, then we can find what is fc, this guy, based on the information that we have. So let's create this particular code. Okay, so we're gonna say interpolation, and let's go ahead and copy the table. So it's gonna be A, B, and C. So A, B, and C, and A is equal to 2, 2.6, and 3. 2, 2.6, and 3.0. Okay, then we have 60x 68. So 60x and 68. Okay, and it's telling us that the way we can find FA, or FB, I'm sorry, is saying, first of all, we have to say that this is FA, this is FB, and this is FC. All right, then we need to find FB, the function at point B, and this is FA plus B minus A. So let's use parentheses, B minus A divided by C minus A. Careful with parentheses. This is a crucial point. All right. And then that is going to be multiplying, more parentheses, FC minus FA. So F at C minus F at A. So even though here we're using brackets, we know that brackets are used for arrays in C and C++, therefore every single operation will have to have parentheses. So FC is a number, and FC is basically what I called Y, is the function evaluated at point C, so is the value of Y. And then we need to find that. So we don't even need a for loop or an if loop. This is extremely simple. It will be more interesting if we have to do a list of numbers, but right now we're only doing a single one. So let's do our usual suspects, which are includes, input, output, stream. Okay, and using namespace standard, I'm gonna do int main. All right, excellent. I have my return 0. All right, so right here, I'm able to use the compiler and create my C++ code. So what I want to do is create double, let's do floats. A float A, which is equal to 2.0. Float B, which is equal to 2.6. And a float C, which is equal to 3.0. Nice. All right, now I'm gonna do FA. So let's do the same thing, float FA. So of course I can't put parentheses because then the compiler will understand something else. Right now it's gonna think it's a function or something else. Therefore my variable is gonna be called FA like this. and the value is 60.0. And notice that I'm not using int, because if the answer is not an integer, then I'm gonna be in trouble. We're gonna do another one, which is what we're gonna be finding, which is fb, and we're gonna just call it 0. fb, initialize it at 0. And we're gonna use another one, which is fc, and this is gonna be 68. Perfect. So of course the numbers right here could be from a file, could be inputted by the user. The important thing is that you get your variables and you know how to use them. And we know how to use them. We're going to use this formula. And we're going to say that FB equals FA plus, then we said that we're going to basically use parentheses for this part, B minus A divided C minus A. Excellent. Times parentheses FC minus FA. And that's the end of my line. I am going to do a cout. Printing FB and an end of line. And then here I only have to say the value of FB equal is, and then if we run it, we should be able to get the value of FB. Okay, no errors, that's good news. And we get 64.8, and here we got 64.8. Excellent. So this is how you do interpolation. Of course, if you want to do more than one interpolation, then more than one interpolation point, then you're gonna have to ask for more points. But the point is that this is pretty much the formula to get your point interpolated in 2D. If you wanted to ask the user for numbers, in that case what you need to do is initialize them with 0, or just not even initialize them, just declare them a comma b comma c, and then here as cout input the value of a, then cin, a is the value that the user inputted, and basically that's what you need to do for your homework. Okay, so now we're gonna talk about pointers. And pointers are one of the most powerful concepts in computer programming, and they are available in C and C++. Pointers are useful because they make your code much faster, much more optimized. So you remember how before we knew about pointers, we talked about how variables are allocated in memory. So memory, your RAM, has a physical address, and it could be hexadecimal or something like, I don't know if you've seen XB something or other 0, 1, 6. It's a physical address, and then that will put a number down, let's say 4, or x equals 1 here, or whatever number you save in memory. You basically save your variable, and the compiler will do whatever it needs to do to find a place in memory and allocate it. Well, with pointers, you have access to that location in memory. And instead of every time you find x equals 4, every time you need to use the variable x, instead of having to go and grab the 4 and take it to your program, do a computation, go save it somewhere else, put 4 where it was, and the new computation is going to be 4 plus 1. So you took this one plus that one, and now it's saved in memory. Instead of doing that, you're going to do something much more efficient. It's a little better in terms of runtime. And instead of saying, okay, let's take this variable, carry back to the code and use it, put it back where it was, we're going to say, no, let's just use the address. Let's use, instead of going to my house, let's just write down the address so that you know that those are the places that my things are stored at. So later when we go grab all the things that we need, we'll go to my house and your house and the store that has the address of X, Y, and Z. Before we were going to my house, then going to your house and going to the store and grabbing things, where now we just have a list of directions and we say, okay, well, with that, we know that my house is this address and the store is this address and we need to go to this address. Okay, well, I don't really need to go to my house because I already have what I need and I only need my house to give the clerk the information to, to pay or to send me what I want to buy. So pointers are something similar. Pointers are, instead of having to go physically to the place where the memory is allocated in my variable, I'm going to use the address. So now instead of using x equals 1, when I use a pointer, I'm going to use the address where x is located at. And in that case, I don't have to grab my variable at all. I just know that the compiler knows where the variable is and is located at, and it can point at it saying, okay, that variable right there, basically pointing at the variable. You see the variable that I have right there, that 4, use that and add it to 1. So it's much faster. The address of the memory location that we're talking about is accessed with this ampersand. So the pointer is the asterisk. It's not a multiplication right here. When you declare a pointer with your type of variable, that this asterisk is a pointer. And it's basically telling you where the variable is located. And then the address of the pointer is the ampersand. Okay, so let's look at some examples. All right, so let's create a first pointer example. Okay, so let's start with our header, include, and in this case we're going to use standard C because pointers are both in C and C++. And we're going to call our main function. And then we're going to create a character array. So this is going to be an array of characters, kind of like hello is an array of characters containing H, E, L, L, and O. This array of characters is called S and is going to be the word string. And we're going to say for char or character who's a pointer called CP is equal to S, and S is our list or array. Use the pointer CP, which when is not equal to 0, and go 1 by 1, CP plus plus or plus plus CP. Okay, so we don't need brackets because we're only going to do one line. And what we want to do is a printf since we're using C standard library, we can use printf. And what we're gonna do next is we're gonna say the comment with pointers the array S contains, we're going to output a character, %C, jump line, and we need a comma CP, and this is going to be a pointer CP. Okay, and main. Return 0, and let's see if we have any errors. Yes, one more bracket. All right, no errors, and run it. So with pointers, the array S contains string, right? So this was pretty much the for loop that we used for homework 3. We use a for loop where we're gonna say that as long as CP doesn't find an empty location in memory, go one more space in memory. So as you saw in the slide here before, the pointer needs to be initialized as something. So this pointer is type character, and the pointer is called CP. And then when CP is not equal to 0, meaning that when you go to your place in memory, for instance here, back to my memory example, and you save string, which is S T R I N G, this is located somewhere in memory. Each character is a combination of zeros and ones. We saw this before. And so it's saying that take this portion of memory, and as long as it's not equal to 0, one position, then print what you see. Because here, you'll have a 0. So not 0, print S, not 0, print T, carry on R, I, N, G. It is a 0. Stop. This is what we're doing here. So this is a simple example to show how pointers work, and you can do this for your for loop when we learn how to create a vector or go through your array. This could be an array of numbers, an array of floats, double, whatever. In this particular case, we have an array of strings. Sorry, an array of characters. Okay, so that's how pointers work. It's very simple. It's the same concept, except for now it's more efficient. Let's do another example. With this example, we can say include, and then we're going to use standard input output.h, which is another library where printf could be found. And then we're going to say in main, and then return 0 if successful. And then we're going to create a variable a, type integer, and we're going to create a pointer with its type int as well. And for that, we're going to create a pointer with the asterisk. This means that is a pointer. All right, so the example says that we want to print pointer example. Let's see. Okay, so I don't think we need to print that line. It's just saying that it's a pointer example. Let's say, so we're gonna say my A equals to 10. So actually I could say that here. A is equal to 10. And I'm gonna say that pointer is equal to the physical address of A. Okay, so now I am actually saying that my pointer, the same way that before I was able to declare it there, I can also declare it here. So pointer equals to physical address of A. And if we run this, I'm gonna call this pointer example 2. You have no errors because you're basically saying that you're initializing the pointer to the location in memory of A. Okay, so let's print all this. Print. All right, and we're gonna say quotation mark, jump line, and we're gonna say A equals percent %d because it's an int, comma A. Printf equals percent %d, comma A. It's not liking what I do. A equals, oh, it's printf, I'm sorry. Yes, printf. All right, so this should tell us that A equals 10. Good. Now, A equals this. I'm gonna copy this line and say that the next one is my pointer. So asterisk pointer equals to, and this is a type int, then I can use percent %d, and I'm going to be printing my pointer, and pointer equals 10. Excellent. I think I need something else here because it's gonna get a little messy. Jump line, okay. All right, good. Now the third one is the address. So the address of A, which is a type address, and in that case we're gonna say it's not percent %d anymore, it's percent %p, and we're going to be printing the address of A. Excellent. So the address of A, the physical address of A in my RAM is this hexadecimal number. And this is where, if you go to your RAM looking for this address, you can basically tell Amazon to take your information there. So this is the physical location of where my A value is located at. So 10 is an object and lives, in this particular case, and this is renting this space, if you want to think like that. This is how we remember. So 10 is in this physical location. This is the address. Then we have that the pointer pt should be able to also give us the address of that variable A. So for that particular case, we can do pt pt equals to pt. Excellent. So notice that a is equal to 10, and the pointer is telling you that is 10. So it's pointing at 10. Similarly, the address of A is this, and the value of PT is this, which is the address of A. So pointer with asterisk is actually what it's pointing at. The pointer with no asterisk is the address of A. All right, we're not done. Then we can get also, there's two more that we can do. And in this case, we can do ampersand PT. And then ampersand PT, printing here. Excellent. So, of course, the address of my pointer is different than the address of my variable, because pointer is also an object. And if you ever need to point to the pointer has this address. So it's an actual object, exists in memory, and it's not just memoryless, has this location in memory, even though the value is to point to a variable. All right, and then we have I think we already did this one. Yeah, so pointer is the same as this one. Excellent. So yeah, I think this is good. Let's review. Let's run it one more time and run it, and we have that a variable with value 10 is being used, and we're printing that variable right here. And then we're using a pointer to say, okay, that pointer is going to be equal to the location of A. So if you want to see what it's pointing to, you print the pointer with asterisk, and that is basically the value of the variable. Except for now, it's much more efficient because you're pointing to it instead of telling the memory, instead of telling the compiler to go and grab the value of A, carry it back to the code, use it, take it back to memory. Right now, you're just saying, hey, look, that variable that you see over there with this location, with this address, I want to use it. And the value that I'm pointing at is 10. The location in memory of A, the original variable, is ampersand A, and the pointer knows what that location is because that address is assigned to the value of the pointer. And of course, the pointer is an object, so you can also save or ask for the address of the pointer if you need to save it or use it later on. Okay, so this is an important part of any programming class, which is input and output file. So input file data and output to file, writing or appending information to a file. This is important because project 1 is based on this concept. We're going to be writing and reading a file of numbers, and we're going to organize the data. So let's see how we do that. First of all, to read a file, the file must exist, and not only the file must exist, also the program needs to locate the directory, the location where the file is. If the file does exist but is in a different location, the path to the file doesn't exist, then really the computer thinks the file doesn't exist. So it's going to give you an error. In other words, the file needs to exist and the path to the file needs to be accurate. That's basically step number 2 is that the code must know the location of the file. So if it's the desktop, downloads the same folder where the script is located at, that's usually what I do. I save my file that I'm gonna write or read within the same folder where my script is located at. The file must dwell in the same folder. Again, saying the same thing. And there's this function called fopen, file open, to be able to access the file, either to write, read, append, whatever you want. So let's talk about the file open function, which is very important. So exists and the standard input output.h. This is the header file. So every time you want to use fopen, you have to include the standard input.h. The first argument is the file string. So if you notice, this parenthesis open and close means it's a function, and the first argument is always the file name. So if your file is text file, then you're gonna write text file in that parenthesis with quotation marks. The second argument is a string representing the file mode. So if you're gonna read, if you're gonna write, if you're gonna append, if you're gonna edit, whatever you're gonna do, you have to let fopen know what's your intention. All right, how to use the function. The function is going to return a file pointer. So we know that the pointer is basically the address where the file is. And the file is a data type structure defined to reference from standard input output.h. In other words, you're going to create a file and the pointer will handle the direction or the address. File versions of standard C input-output functions are used to read from an open file. In other words, every time you read or write to a file, the file will be open. So if you remove the file, there's going to be an error. If you want to edit the file with a different program, you have to let fopen know that you're going to close the file. And if this is important because if you modify the file while fopen is using it, you can get an error later on. As we saw, the function requires the handle as an argument, and the handle is the pointer to the file. And reading functions that are also very common is gets, getC, fscanf, and all these are to start reading line by line or to start writing line by line. So when you're done, make sure that you use fclose, which is the opposite of fopen. Fopen is going to open the file, fclose is going to close the file, and always close the file to avoid errors. The function's argument is the handle file at the pointer, and don't forget to close other open files if the program quits. Sometimes you're opening several files, you need to close all the files. Okay, so let's go ahead and read this file. So we're gonna read Sonnet 18, and for that, I created a folder where I have my file, and this is my file, which I'm gonna upload to Canvas. And Sonnet 18 is sonnet from Shakespeare, and we're going to read this sonnet using C++. So let's go to our code or API, and we're gonna use fopen. Therefore, we're gonna include a header that will let us use fopen, and that will be standard input output.h. We're gonna do int main, which is my main function, and we're gonna use or open brackets with a return 0. Good. So first of all, we're gonna read our file, and for that we're gonna create a constant variable, which is gonna be called file name, and it's gonna be an array of characters. So we're gonna do const character type and file name, which is an array with this particular name. So, and this, as we saw before in the all previous example, we not the pointers, but the example where we use character array. This is going to be an open array until I assign the space that I need, and the space that I need is this 1 2 3 4 5 6 7 8 9 10 11 12. So we're going to be 12 characters on part of this string called sonnet18.txt. So the extension is important. You need to let program know the extension. In my case it's txt, but it could be something else. And we're going to create a pointer, capital file, pointing at fh. As we saw before, this is a pointer. And then we're going to say that fh is equal to fopen, and the arguments of fopen are going to be my file name, comma, what I want to do, which is read. I don't want to write to it, I want to read file name. Okay, so let's see if I have any errors so far. So make sure that you read and write your script or your text file within the same folder, otherwise you would have to add the path to the file. And we're going to say read example1 or read sonnet, and no errors. Excellent. It's going to print nothing because I haven't, it's not going to print anything because I haven't designed my output yet. But for now I'm going to say if the file name does not exist or is corrupted or is a different file name, show an error saying that the file name is not exist, please input the right file. And then for that we're going to say if fh, my file pointing at a file name, is equal, meaning is equal to null, or we saw this from Boolean operators, is if it's a null operator, if it's a not successful, if it's a zero, null, meaning this not getting any information from this file, then do the following, which is open brackets, print f on a capital U, unable to read the file, and we're going to use a string to say the file name that the user is inputting. So if it's inputting something that is not what I have saved in my file, then it's going to say that file name that you inputted is not correct. So probably there was a typo or something, the user will know that has to fix it. And then we're going to say return 1 or break, whatever you want, just stop the code. Else, or in any other case, if it's correct, we're going to say print f file and %s because we're doing a string. So s opened and file name. Excellent. As we said before, we want to f close our pointing element to the file, and we should be able to run this with no problem. Okay, so file sonnet 18.txt opened. Okay, excellent. You can also ask for a user to input the file or whichever you decide is best. This is H. In this particular case, I just want to write the name so that I can read it. So later we're going to actually read the file. Right now we opened it and we closed it. So you can pretty much save this as the script to always make sure that you open the same, or to make sure that you always open the right file. And now what we want to do is we are going to read the content of the file. Okay, so in that case, what we need to do is add a few lines, and we're gonna do before we close the file, so we can keep using the file. We're gonna say while true, while 1. So we're gonna say say ch string ch equals f get c fh. Now if ch equals end of file, then return 1 or break. And what we want to do next is that we're going to say put char ch. All right, let's see what we get here. String ch. Yes, string ch should be a character. Input, and the error is put char. All right, so let's run it again. No error, and run it, and there you have it. Good. So file opened, and then we read the file. Excellent. So notice that it's always true except for when the character finds the end of line. Okay, the end of line is right here, and when character finds end of line, it simply breaks the program. And in that case, it just had printed the line before the end of line, which is this. And then we're closing the file. Yes, we are. So this is good. This is good code to read the file. So study this. Notice that here I needed to either up here initialize the variable, or right here you need to tell it that ch is a character. Otherwise it's gonna say the initialization variable is not declared.